Lesson 20.1, Task 1. So we're going to choose among linear, exponential, and quadratic models. So we're trying to figure out which model would best represent a set of data. All right, so evaluate models for a data set. Given a table of data pairs, x and y values, you can use several tools to determine which type of function best models the data. You can graph a proposed model on a scatter plot of the data and visually assess how well the model fits the data. You can also plot the residuals for the model. If the points on the residual plot are close to the x-axis and appears randomly distributed above and below the x, then the model fits the data well. All right, so we did not study residuals. We kind of skipped that part and just did this on the calculator. So looking at this, all you have to know really is if the residual plots are close to the x-axis, then that means the model fits well. And we are going to go in the next task straight into using your calculator with this as well, because I do feel like that's an easier, kind of quicker way to do these, especially if it's on a standardized test. All right, so the table shows the data from the Spark Your Learning page that gives a boat's value, y in dollars, at time x in years after the boat was purchased. All right, so we are given a table of values, and it says below are the linear, exponential, and quadratic functions obtained by performing regression on the data. Following each function is the graph of the function on a scatter plot of the data, and then a residual plot for the function. All right, so just as a reminder, I'm going to go through and show you how to do this on your calculator. I'm going to hit second plus, and I'm going to clear my list just in case there's something in there from the previous example. So I'm going to hit clear, and now I can go back to stat and hit edit, and now I can enter my data. So I'm going to go from 0 to 8. All right, now I'm going to move over to L2 and enter the other column here. So 20,000, 16,100, all right, and again, be careful to make sure the numbers are entered correctly. You're only going to get accurate data if you have the correct numbers in your table. All right, so once I have my table set, now I can go back to Y. And again, if our stat plot is on, it is on from the last time. We hit graph, and we need to change the window because now these go from 3,300 all the way up to 20,000. So again, we're not going to see anything unless we make our window fit this set of data. So let's go down. This is my y values. My x is from 0 to 8, so I don't have to worry about -2 to 12. Everything's going to fit on the x. So all I need to do is come down to the y values and make sure that my y value is a little bit above 20,000. So let's put in 20,100. All right, and the scale, all right, we want to go by 5s, 10s, 50s, 100. Let's go by 500s here because these numbers go all the way from 33 up to 20,000, and this will just make the data fit the graph a little bit better. All right, so we can see this kind of looks like a curve. It does not look like a line. A line would mean it was linear. So this is probably either quadratic or exponential decay. All right, so what they did was they graphed this and they looked at the r squared, or that's what we're going to do is look at the r squared. But they graphed this point and they typed in linear regression. Well, linear regression puts the line on here, and you can see that the points are not really, they don't really hit that line, so it's not a good model. And this is the residual. Again, we didn't study residuals, but if these dots are all close to the x-axis, that means this line falls close to the data set. These points are all over the place, so the linear regression, this equation or this model, is not a good fit for that table of values. All right, then they did exponential. The exponential, you can see the residual, they're very close to the x-axis. You can also see that on this graph here, this line goes through every single point. So this is a very good model, a very good equation for that set of data above. They also did a quadratic, and with quadratic, it hits a lot of the points. It looks kind of close. These are a little further from the x-axis. This is an okay model, but it's not as good as the exponential because, again, the exponential, they're hovering right on that x-axis, which means that's a really good model. All right, so how would you do that? Using your calculator. All right, if we want to find each model, okay, I can hit y equals, but then if I go back to graph, I'm going to hit stat, calculate, and I can do linear, quadratic, and then exponential is on down a little bit further. Let's do linear first. And it will calculate your A and your B. So y equals ax plus b is your standard equation. All you would have to do is plug in A and B. This shows you that your r is negative 0.97, r squared is 0.94. All right, so it's not terrible, but it's not really the best model as we've already seen. So if we hit stat again and hit calculate, this time we're going to do quadratic regression just because it's next. And you can see it gives you your A, B, and C. And again, you just plug those into the standard form equation here. All right, your r squared for this one is 0.998. So that's pretty good regression, as you can see before. This one's not a terrible model. It kind of looks pretty close to here. But let's look and see what the exponential looks like. So if we scroll down, you have to scroll down till you see exponential, EXP, so exponential regression. Hit enter. And see, now this gives you your y equals AB raised to the x power. This is my A, this is my B. We plug it into the equation. And you can see that the B is less than 1, so that means it is exponential decay. And you can see the r squared and the r both are 0.999, which basically rounds to 1. So that shows that this is the best model. So if I go to y equals, and I do vars, and I do number 5, stat, and I come over to equation, it's going to copy that equation into my graphing part of the calculator. So now it will graph that line, which is what you see on here. Well, actually the one right above it. Right here is the exponential model. You can see that this model is similar to what we had here. Okay. All right, so let's see what the questions ask. All right, so it says, how do the linear functions graph and residual plot suggest that the function is not a good model for the data? Select the phrases to complete this statement. The linear function does not fit the scatter plot of the data points because the data points follow a curve, not a line. The points on the residual plot for the linear function are far from the x-axis and are not randomly distributed above and below the x. So that just says basically that that's why the linear function did not work. Okay? All right, so moving down to the next one, the graph of the exponential and quadratic functions. Both are close to all the data points. Which function do you think is the best model? Select the words to complete the statement. The graph of the exponential function is slightly closer to the data points, and the exponential function continues to decrease over time, as you would expect the boat's value to do. So since we were talking about the value of a boat, it is going to continue to decrease as the boat gets older. A quadratic model would go down to the vertex and then start increasing again. So that usually doesn't happen when you're talking about the value of a house or a car or a boat. All right, that's all for task 1. If you have any questions, let me know.